After 46 years in deep space, Voyager 2 has finally crossed the edge of the solar system, and what it found has left NASA stunned. Instead of silence, it encountered turbulence. Instead of a boundary, a breathing, shifting storm. The spacecraft recorded magnetic twists, leaking solar winds, and even the eerie sound of interstellar space itself. This isn't just data, it's a revelation. Our solar system's edge is alive, unstable, and more exposed than anyone imagined. Could this change how we view the entire galaxy? Stick around, because Voyager didn't just cross a line, it uncovered a hidden world beyond it. Crossing the threshold. It's been quietly drifting through space since 1977. But after 46 years, Voyager 2 has crossed a border no human object ever has before, the edge of the sun's influence. For the first time in history, a machine made by human hands has exited the heliosphere, the protective bubble that surrounds our solar system. Voyager 2 didn't just leave the solar system, it entered interstellar space. This moment redefined where our solar system truly ends. For decades, we thought of the planets as the main domain. But now we understand it's the heliosphere, a giant shield of solar particles and magnetic fields that marks the real boundary. As Voyager 2 crossed that edge, its instruments showed a clear signal. The solar wind dropped dramatically, and suddenly interstellar particles began to spike. It was like walking through a doorway into another room, said Ed Stone, Voyager's project scientist. But it wasn't just a drop in wind. The data also showed a sudden shift in energy levels. Outside the heliosphere, Voyager detected particles that had never touched the sun. These were pure samples from the galaxy beyond, unchanged by our star's reach. That's what made this so important. Voyager wasn't just far from home. It was now a listening post in the space between stars. With this leap, Voyager 2 became more than a spacecraft. It became a historical marker, a floating monument to human exploration. We now have a direct presence in interstellar space, NASA said, and it's giving us a front-row seat to the galaxy's raw energy. Voyager 2 didn't just escape the sun, one mission engineer said. It opened the door to the rest of the universe. But what Voyager 2 found beyond that door wasn't silence. It wasn't peace. The edge of our solar system wasn't a hard shell. It was more like a stormy coastline. And as Voyager crossed it, it found itself surfing through chaos. The heliosphere isn't a For years, scientists pictured the edge of the solar system as a smooth, clean bubble where solar influence stops and galactic space begins. But Voyager proved that idea wrong, completely. Instead of a simple boundary, the edge of the heliosphere was wild. Magnetic fields swirled unpredictably. Plasma densities rose and fell like crashing waves. It wasn't a wall, it was a cosmic surf zone. Voyager's instruments picked up dramatic changes in every direction. The magnetic fields didn't just shift, they spun. Interstellar plasma came crashing into solar winds, creating sudden shocks and unexpected currents. We saw turbulence like nothing we expected, said physicist Merab Ofer. It's a dynamic, living edge. Instead of one clean line, Voyager passed through multiple layers, each with different temperatures, densities, and wave patterns. The idea that the heliosphere is layered wasn't new, but until now it was just theory. Voyager's real-time data showed at least 3 nested zones, each one pulsed and moved as if breathing. These were not static borders. They expanded and contracted. The entire boundary region shifted daily, depending on solar activity and galactic winds. The edge of the sun's reach wasn't solid. It was shifting sand in a galactic storm. What shocked NASA the most was how much this region defied their models. Decades of predictions were blown away in weeks. Voyager 2 showed that the outer solar system is far more chaotic and alive than anyone had imagined. The old image of a calm bubble has been replaced by something far more dramatic, a boiling, turbulent interface between 2 cosmic oceans. It's not the edge of a balloon, one researcher said. It's the shoreline of a crashing sea. And when Voyager surfed through this storm, it wasn't just the wind and plasma that shifted. The magnetic fields, the invisible lines that tie the galaxy together, did something even stranger. They didn't break, they bent. Magnetic shock. As Voyager 2 pushed through the heliopause, the boundary between solar and interstellar space, its magnetometer picked up something unexpected. The magnetic field didn't stop at the edge of the sun's influence. It kept going, it spiraled. Instead of disconnecting cleanly the sun's magnetic field seemed to be twisting into the galactic field beyond. This wasn't just surprising, it was shocking. The field Voyager detected was stronger than anyone expected. Not only that, it was angled. It didn't match what models predicted for local galactic orientation. The direction and twist of the field showed that solar and galactic forces were intertwined. "We didn't find a break," said Dr. Leonard Berlanga, who led Voyager's magnetic analysis. "We found a handshake, a magnetic handshake between the sun and the galaxy. This changes everything we thought we knew about magnetic space. It suggests the sun's influence may spiral outward far past the heliosphere, blending with the galactic field in complex ways. It also means that energy from outside, cosmic rays, interstellar winds, might follow these twisted paths back into our solar system. We're not cut off from the galaxy, we're magnetically connected to it." Even more surprising was the potential for magnetic reconnection events, violent bursts where magnetic fields twist, snap, and reconnect. These events could happen far beyond the sun, even out in interstellar space. They might release massive energy and reshape how particles flow between systems. Voyager's instruments may have already caught the signatures of such events, flashes of magnetic warping that hint at deeper galactic weather. "The sun doesn't just end," one NASA field scientist said. "It blends, twisting its legacy into the galaxy like a cosmic thread." So now we know the boundary isn't a shell, it's a storm. The magnetic fields don't stop, they spiral. But there's one more surprise. The solar system's shield isn't sealed, it's leaking. And what's slipping through may affect Earth more than we think. Leak in the shield. We used to think the heliopause, the edge where solar wind stops, was a clean seal, a force field separating the sun's influence from the rest of the galaxy. But Voyager 2 shattered that idea. Its sensors picked up something both subtle and alarming. Particles from interstellar space were leaking into the solar system, and vice versa. The solar wind was slipping out. The heliopause wasn't solid, it was porous. Voyager recorded bursts of galactic particles, high-energy ions and neutral atoms, pushing into what we thought was a protected space. These weren't just momentary blips. They were persistent flows, like a tide moving in and out. "It's a breach, not a barrier," said NASA physicist Tom Krimigas. "Galactic particles will get in, and solar ones are getting out." This leakage may not sound dramatic, but it changes the way we see space weather. Earth's environment is shaped by the sun, but if galactic radiation can sneak in through these gaps, it might be influencing more than we thought. Some researchers now believe cosmic rays, supercharged particles from deep space, might be reaching us more often than models suggest, and that could affect everything from climate to DNA mutation rates. Even more troubling is what this means for future deep space travel. If the heliopause can't block incoming radiation, then astronauts on long missions, say to Mars or beyond, may face more exposure than expected. And since the boundary is constantly moving and fluctuating, those risks could spike suddenly without warning. We're learning that the shield around our solar system is more like a sieve, and Earth may be more vulnerable to the galaxy than we ever imagined. "It's not a wall," said one mission analyst. "It's a leak," and that changes the story completely. But the biggest shock didn't come from what Voyager saw, it came from what it heard. Because space, we always assumed, is silent. But Voyager 2 proved that interstellar space sings. Voyager hears the interstellar medium. In the darkness beyond the heliosphere, Voyager 2's plasma wave detector picked up something unexpected. Sound. Not sound in the traditional sense, like what we hear through air, but vibrations, oscillations, real low-frequency plasma waves rippling through space. Voyager had entered a region that wasn't quiet, it was alive with motion. These signals were faint but unmistakable, ghostly hums echoing through the interstellar medium. They rise and fall. Some come in steady tones, others flicker like a broken melody. Scientists believe they may be the long-decayed echoes of supernovae, ancient star deaths sending out waves that still ripple today. "This is the music of the galaxy," said Don Gurnett, who led the plasma wave team. "And Voyager is our first ear in the void. These waves tell us more than just that space is active. They help us map the density of interstellar plasma. By measuring how fast and loud these pulses move, scientists can calculate the thickness of the medium, how many particles are out there, what temperature they are, and how fast they're traveling. It's like using sonar in a vast ocean of nothingness. But some of the sounds Voyager detected are still unexplained. One type of oscillation repeated every few months, consistent, patterned, and oddly timed. Are they the result of galactic winds, rotating magnetic fields, or some kind of galactic weather system we haven't identified yet? Whatever the source, these echoes prove that the void between stars isn't silent. It isn't dead. It's just been speaking in a language we've only now begun to hear. "Space isn't empty," one NASA plasma physicist said. "It's singing, and we finally have a microphone." And just when we thought the outer edge was simply buzzing with waves, Voyager sent back a final surprise. The boundary wasn't fixed, it was moving. And not over centuries, but days. Beyond the boundary. When Voyager 2 crossed into interstellar space, scientists expected stability, a clean jump from solar influence to galactic calm. But what they found was far stranger. The plasma density on the other side wasn't just higher than expected, it was fluctuating. Rapidly, instead of a steady edge, the heliosphere's boundary seemed to pulse, shift, and even breathe. Plasma density levels jumped up, then fell. In some cases, they changed within hours. This was a total surprise. The outer regions of the solar system were expected to evolve slowly over decades or centuries. But Voyager proved that the edge of our system is dynamically alive, reacting not only to solar outbursts, but to galactic conditions as well. These fluctuations may be driven by the solar cycle, an 11-year rhythm where the sun's magnetic field flips and activity spikes. As solar storms push out stronger winds, the heliosphere expands. In quiet years, it shrinks. But Voyager's data also shows influence from beyond: galactic pressure from cosmic rays, ancient clouds, and interstellar winds that push back. It's a tug-of-war at the edge of our world. The shape of the heliosphere is also more distorted than expected. It's not a sphere, it's lopsided, with a compressed front and a stretched tail, more like a comet than a balloon. This shape shifts in real time, which means the boundary Voyager crossed is not the same today as it was when the probe passed through. The edge is moving, living, shaped by two forces in constant battle. "We thought we were stepping over a line," said a mission physicist. But Voyager showed us we were crossing a river, fast, deep, and always changing. So now we know, the edge of the sun's power is a battlefield of pressure, motion, and noise. And beyond it lies an even more dangerous sky, one filled with radiation, chaos, and secrets we're only beginning to see. The cosmic ray gauntlet. Now beyond the sun's protective bubble, Voyager 2 is traveling through a region unlike anything we can simulate on Earth. Here, the spacecraft is bombarded by galactic cosmic rays, high-energy particles that have been flying through space since the dawn of time. For the first time, we're getting unfiltered readings of these particles, hitting Voyager head-on in deep interstellar space. These cosmic rays are dangerous. They move near light speed. They're made of protons, atomic nuclei, and unknown particles. Back inside the heliosphere, the sun's magnetic field helps deflect and slow them. But out here, there's no shield. Voyager is completely exposed. "It's flying through a storm of shrapnel," said Dr. Rob Decker, a mission scientist at Johns Hopkins. "Every reading is like a bullet in the dark." But here's what surprised scientists most: the intensity of the radiation changes. The amount and energy of these cosmic rays isn't constant. It varies, creating patterns, spikes, dips, sudden shifts. That's something nobody predicted. Some think it's the result of galactic magnetic fields, shaping the flow of particles like wind shapes ocean waves. Others suggest we may be detecting a kind of cosmic weather, driven by events light years away, like supernovae or the movement of interstellar clouds. The implications go beyond Voyager. If these patterns reach Earth, they could affect more than satellites. They might influence climate, electrical grids, even mutation rates in DNA. Some mass extinction theories even tie spikes in cosmic radiation to biological collapse. Voyager's data is opening new doors, not just in astrophysics, but in how we understand our planet's relationship to deep space. This isn't just science fiction, said one space radiation analyst. These particles are real, and they're shaping the universe, and possibly us, in ways we're only beginning to measure. But while invisible radiation rains down from beyond the stars, Voyager's instruments have also caught something solid, something small, dust, microscopic, specks that are ancient, distant galaxies debris reaches Voyager. Tiny grains, barely measurable, floating through the dark. But to Voyager 2, they're gold. Interstellar dust particles, smaller than a grain of sand, are now striking the spacecraft. Each one carries chemical signatures from exploded stars, ancient collisions, and dead planets. Voyager has become a kind of archaeologist, digging into the galactic fossil record, one speck at a time. These particles are made of carbon, silicates, iron, and sometimes more exotic materials. They aren't random. Their composition tells us about the stars they came from. Some were forged in supernovae, others in the cold outer layers of dying stars. Some are even older than our sun, tiny survivors from a time before the solar system formed. Each dust grain is a time capsule, said astrophysicist Dr. Jessica Sunshine. It carries the chemistry of worlds we've never seen. By analyzing their angles and speeds, Voyager's sensors are revealing something else: the direction of galactic flows. These particles don't just drift. They travel on streams of motion shaped by galactic gravity and magnetic forces. Voyager is helping us map how matter moves through the Milky Way, how it flows between stars, how it seeds new systems, and maybe how life itself spreads across space. Because this dust doesn't just tell stories, it may also plant beginnings. Some theories suggest interstellar dust plays a key role in the formation of planets and the origins of life. Certain molecules, organic compounds, can ride inside these grains, protected from radiation. And when they fall onto forming planets, they may help kickstart biology. It's called panspermia, and Voyager might be flying through the very seeds of cosmic life. This dust is more than dirt, said one planetary scientist. It's evidence of explosions, of creation, maybe even of beginnings. But amid this stream of known particles, Voyager detected something else, something that didn't fit, something high energy, high frequency, and completely unexplained. Unexpected particles. It started with a blip, a flicker on one of Voyager's older instruments, then another, and another. Not cosmic rays, not solar particles. These were high-energy particles, fast, powerful, and completely alien to our models. They came from no known direction, matched no known profile. Voyager had found something new. At first, NASA thought it might be a glitch. After all, Voyager is over 46 years old. Its tech was built in the 1970s. But the data kept repeating. These weren't errors. These were real events, bursts of unknown particles passing through the spacecraft's sensors. It's like hearing a sound you have never heard before, said a Voyager telemetry engineer, and realizing it doesn't match anything in your library. The leading theories are wild. Some scientists believe these could be the remnants of ancient supernova shockwaves, still moving through the interstellar medium. Others think they may be dark matter decay events, rare theoretical interactions that produce particles we can't see with regular detectors. And then there's the most radical idea, that these particles point to new physics, phenomena we don't yet understand. These rogue energies don't act like solar particles. They're faster, less predictable, and sometimes they seem to arrive in clusters, suggesting they're tied to some distant, repeating event. They might be coming from deep space structures we haven't discovered yet, like galactic filaments or unknown fields. And if they're real, they could force us to revise the Standard Model, the foundation of modern particle physics. For now, we don't know what they are, only that they're out there, and Voyager 2, battered and aging, is still picking them up. Every strange particle it detects is a whisper from a deeper, darker layer of the universe, a message we haven't decoded yet. "We're flying blind," said one theoretical physicist, and somehow, Voyager is lighting up paths we didn't even know to look for. So now, beyond the heliosphere, beyond magnetic fields and galactic dust, Voyager is catching glimpses of something stranger than science has words for. And somehow, it's still running, still listening, still reporting from the edge. Voyager's aging tech, still breaking barriers. Voyager 2 was never built for this. It was designed in the 1970s with memory smaller than a modern wristwatch and a data rate slower than a dial-up modem. It ran on 8-track tape in handwritten code, and yet, it's still going. Over 12 billion miles from Earth, it's still sending signals home, barely audible whispers, taking over 17 hours to reach us. Traveling at the speed of light, the spacecraft runs on decaying plutonium. Its power levels drop every year. Some instruments have been shut down to keep the core systems alive, but it keeps transmitting, a flicker of humanity moving through total darkness. Every signal that reaches Earth is a miracle, captured by the Deep Space Network, cleaned up by engineers, and hand-decoded line by line. "Every transmission is a heartbeat," said Suzanne Dodd, Voyager's project manager. "It means it's still with us." But Voyager isn't just lasting, it's teaching. Engineers study how its old systems handle radiation, temperature swings, and time. Every failing component becomes a lesson in durability. Every reboot is a case study in resilience. It's helping NASA design future deep space probes that could last a century. "Voyager's not just a mission," said one systems engineer. "It's a living lab on how to stay alive when you're the loneliest object we've ever made." And as it pushes farther into the void, Voyager reminds us that exploration isn't about speed or size. It's about endurance, about showing up again and again, even when nobody else can. It's a message written in metal, floating silently into a galaxy that doesn't care, but still receives it. Voyager proves that sometimes the best technology is just the will to keep going. But the data Voyager sends back isn't just about us. It's becoming a blueprint, because now that we understand our heliosphere, we can start looking at others, other stars, other systems. And the question becomes, how many of them could protect life too? A map for the stars. Until Voyager crossed the heliosphere, we didn't truly understand what a solar system ends with. Now we know it's not just planets and dust. It's an astrosphere, a magnetic bubble that shields against galactic radiation. And here's the key. Every star has one. That means Voyager's data doesn't just explain our sun, it helps us understand stars all across the galaxy. Astrospheres can be small or massive, strong or thin, depending on a star's type, age, and activity. Some may be tight cocoons, others loose clouds. Voyager's real-time readings of how particles behave at the solar edge help us model these other bubbles. "It's like decoding the air pressure of a planet," said exoplanet researcher Dr. Clara Sousa Silva. "Only now we're doing it for entire star systems." This matters for one reason above all: life. A strong astrosphere can protect planets from deadly radiation. A weak one, it leaves them exposed. Until Voyager, this factor was overlooked in the search for habitable exoplanets. But now we know that magnetic shielding is as important as distance from a star or atmospheric composition. It's the cosmic umbrella that determines whether a world can survive long enough for life to evolve. Already, astronomers are applying Voyager's data to analyze stars in our neighborhood, like Proxima Centauri, TRAPPIST-1, and Tau Ceti. Each system is now being reevaluated with astrosphere dynamics in mind. What Voyager found out there is becoming the new toolkit for understanding which alien planets might be safe, and which are open to the galaxy's full fury. "Voyager turned our solar system into a reference point," said one astrophysicist. And while we use Voyager's data to explore alien worlds, the galaxy itself is not standing still. Because the space between stars is breathing, pulsing with ancient forces that have shaped life on Earth in ways we're only starting to see. The universe is breathing. Galaxies aren't empty. They're filled with plasma waves, interstellar clouds, supernova remnants, and magnetic tides. All these elements move, not randomly but rhythmically. Voyager 2 has shown us that interstellar space has weather, slow, massive, and invisible to the eye. But it's real, and it affects entire solar systems. For decades, we assumed the void between stars was static. Voyager changed that. Its instruments detected large-scale plasma shifts, density fluctuations, and even what some scientists now call galactic seasons, patterns that evolve over tens of thousands of years. These aren't small storms. These are waves of change that wash over solar systems, affecting planetary climates, radiation levels, and maybe even evolution itself. Some researchers now believe that as the sun moves through the Milky Way, dragging Earth along with it, we pass through interstellar clouds, dense regions of gas and dust left behind by ancient explosions. These clouds can compress the heliosphere, letting more cosmic rays in. They might have caused mass extinctions, climate shifts, even genetic bottlenecks in Earth's history. We've always looked to the sun for answers, said NASA's heliophysics lead, but now we're learning the galaxy has a hand in shaping us too. This realization reframes our place in the cosmos. We're not just orbiting a star, we're sailing through a sea, one with currents, storms, and long-forgotten tides. And Voyager, fragile and ancient, is our weather buoy, measuring forces so vast they defy human timescales. Space isn't still, one Voyager data analyst said, and it moves, it flows, and we're floating through it whether we like it or not. And now, as Voyager rides that galactic tide, it carries something else. A message, a gift, a golden whisper from Earth, still echoing through the stars. Voyager 2 is a voice in the dark. Voyager 2 isn't just a machine, it's a messenger. On board is the Golden Record, a 12-inch disc made of gold-plated copper, carrying the sights, sounds, and greetings of Earth. It includes music from Bach and Chuck Berry, greetings in 55 languages, the sound of a baby crying, whale song, a kiss, a heartbeat. It's our cosmic greeting card, sent to whoever or whatever may one day find it. The record wasn't meant to be practical. It was meant to be beautiful. A symbolic gesture that says, we were here, we thought, we wondered, we tried. And even now, as Voyager 2 moves farther from Earth than any object in human history, it's still transmitting, still listening, still whispering through the dark. Its journey isn't just science, it's philosophy. Voyager has become a mirror, reflecting how small we are and how far we're willing to reach. It's proof that curiosity can outlast politics, budgets, and even lifespans. The engineers who built it are aging, some are gone, but the craft remains, a story in motion. And maybe that's what Voyager really is, the first line of our cosmic autobiography. A fragile voice saying, this is who we are. Whether or not anyone ever hears it doesn't matter. What matters is that we sent it, and we still do. Voyager isn't just exploring the stars, said Carl Sagan. It's carrying the soul of humanity with it. Voyager 2 was launched to explore the outer planets. Instead, it became our first ambassador to the stars, revealing that the edge of the solar system is not an end, but a gateway. What it's discovering out there is changing how we understand space, shielding, and even the conditions for life. With every faint signal it sends back, we get one step closer to answering the biggest question of all: what's really out there? One thing is certain, Voyager's mission isn't over. It's only just begun. Subscribe for more, because the universe is talking and Voyager is still listening.